Alrighty, welcome back to Fun Maths. Today we're looking at stationary points. So essentially what you need to know about stationary point is it exists on a graph where the gradient is equal to 0. And in particular with this particular exercise where we're looking at applications of differentiation and also anti-differentiation, we know that at these particular points the derivative, which is the gradient function, is where we're going to make it equal to 0. That's where the stationary points are going to occur. So you can see with this particular graph here, it shows some stationary points. So here at this particular point where the gradient of that tangent is 0, it's a stationary point here at A. Likewise, you can be coming down here where you've got a stationary point of inflection. Here where it sort of changes gradient to 0 here, it's a stationary point. Likewise, at this particular point here, the tangent, or the gradient of the tangent is equal to 0. It's another stationary point. So let's have a look at this example here, how we would go about finding stationary points. So the first one here, we've got the equation y equals 9 plus 12x take away 2x squared. First thing we need to do is work out what the derivative of this particular equation is. We can apply the skills we've learnt previously to be able to differentiate that. Doing that process, you end up with the derivative, which is dy dx is equal to 12 take away 4x. Perfect. Happy days, we've got the derivative. Next, we've said that stationary points occur when the derivative is equal to 0. So what we need to do is to write out the derivative, in this case 12 take away 4x, and make it equal to 0. And then from there we need to solve and find out what x is when the equation here, the derivative, is equal to 0. So obviously writing it out, in this particular case you would rearrange things and perhaps move 12 over to this side. So you've got negative 12, divide both sides by negative 4, and you end up with x equals negative 3. Cool. We've found out the location of the stationary point. It occurs at x equals 3. Further to that, to find out its corresponding y coordinate, you need to substitute this back into the original equation, not the derivative, back into the original equation to find out what its corresponding y coordinate is. So substituting the 3 back into the equation here, you'd end up with 9 plus 12 times 3, take away 2 times 3 squared, which is what they've done here. They've found out that it's 27. Therefore, you can say the stationary point, a stationary point, exists with this particular equation here at the point 3, 27. Next one here, we've got an equation again, and they're asking us to find whether stationary points exist, but they're also putting a restriction on this, saying that we're just looking for values of t that are greater than 0 as possible solutions. So here's how you go about doing this one here. Again, writing out the equation, we need to find out the derivative here. So in this particular case, we're going to be finding out dp dt. So applying the process here to differentiate this, you end up with 6t squared take away 10t take away 4. Again, as we've said, to find out where the stationary points are, we need to make the derivative equal to 0. So writing out the derivative and making it equal to 0, again, you can simplify things down. Where you've written this out, making it equal to 0, on the left hand side what you could do is you could take out a common factor here. So they've taken out 2 as a common factor out the front, and you're left with 3t squared take away 5t take away 2. So that there is just the same as that. It's just taken 2 as a common factor, and it's equal to 0. Yep. From there, we are factorizing this here. So again, you'll need to utilize your knowledge of quadratics to factorize 3t squared, take away 5t, take away 2. In this particular case, it factorizes to 3t plus 1 in the first set of brackets, and in the second set of brackets, it's t take away 2. And that's equal to 0. From this particular location, what you can do is we need to use the null factor law. In order for this expression to be equal to 0, either this part here in the first brackets has to be equal to 0, and we can solve that, or the second brackets here needs to be equal to 0. First of all, to solve this, 3t plus 1 being equal to 0, rearranging things, you get solution as being 10 is equal to, t is equal to negative 1/3. Here, where you've got, where you make t take away 2 equal to 0, rearranging things by adding 2 to both sides, you end up with t being equal to 2. So here are the two locations where the stationary point exists. However, remember there was the restriction, they were looking for just values of t that were greater than 0. So obviously this one here, you can disregard because that's a negative value, it's less than 0. So the one we're after that's greater than 0 is t equals 2. Again, because this is the one that we are that falls into that particular domain, what we're going to do is we're going to substitute this into the original equation to find its corresponding y coordinate. So 2 being substituted into the original equation is as follows, and it evaluates to being 1. So therefore you can say the stationary point is going to exist at when t is equal to 2 and the y value is equal to 1. So there's the coordinates there for that one. This one here, we've got y equals 4 plus 3x take away x cubed. Again, first process with this is to work out the derivative, and then we're going to make the derivative equal to 0 and solve it from there. Okay, looking here at C, so we've got the derivative and we're making it equal to 0. With the derivative, again, you can take out 3 as a factor of both of these terms. 3 comes out the front, you're left with 1 take away x squared in the brackets. And remember, obviously we're finding the stationary point, so we need to make the derivative equal to 0. Again, to solve this here, this here is actually a difference of perfect squares. Again, we know 1 is the same as 1 squared. If you've got something squared, take away something else squared, it's difference of perfect squares. Therefore, essentially, you're going to end up with 1 take away x in one of the brackets. Imagine that's an x, and you're going to have 1 plus x in the other brackets. Difference of perfect squares here. So therefore, solving this, solving 1 take away x being equal to 0, you're going to end up with positive 1. Here you're going to end up with negative 1. So therefore, that's why they're saying here, the two solutions here are x being equal to positive 1 and x equal to negative 1. So given that we've got both positive and negative 1, we need to substitute those back into the original equation, and from there we can work out their corresponding y coordinates. So when x is equal to positive 1, substituting it in, its y coordinate is 6. And when x was negative 1, substituting it in, its y coordinate is 2. Alright, this example here does require some attention. It says here the curve with the equation y equals x cubed plus ax squared plus bx plus c passes through the point 0, 5. So there's some information they're given here. But they're also saying it has a stationary point at 2, 7. And they're asking us to find out what the values of a, b and c are. So essentially we'll need to use these pieces of information here to generate some equations, and then we're going to have to solve those simultaneously. So the first thing that they're saying here is, given that it passes through the point 0, 5, when x equals 0, y equals 5. So if you substitute x equals 0 into the equation, that's 0, that's going to be 0, that's going to be 0. Obviously, it leaves c being 5. Yep. So y is going to be equal to 5 when you evaluate that. So we can get that statement there. Next, what we know is that when you work out the derivative of this particular equation here, it tells us it's got a stationary point at this particular location. So if we differentiate this, which we're doing here, we know that at 2, the derivative is going to be equal to 0. So you can create some equations from this. When the first scenario is when x equals 2, if you substitute that into the derivative here, you end up with 12 plus 4a plus b. When it was 2, we know that it's going to be equal to 0. So that's the first equation that we can get based on that information. The fact that there is a stationary point at 2. Yep. So you make the derivative equal to 0 when x equals 2, and you can create the first equation. Check. From there, the other information that we've got is that on the original equation, there is the actual point 27. So if you consider the original equation and we substitute it in x being 2 and y being 7, we're writing it out as follows, and we can simplify things down and generate a second equation, which we've got here. Check. When you have two equations, from here, with two variables, you can use simultaneous equations to solve them. Now, it's up to you how you go about using simultaneous equations, whether you're using elimination or whether you are using substitution method or whether you're using CAS calculator. Ultimately, you should get the same answer. You will get the same answer with each of these. So, in this particular case, they're doing the elimination method and they're subtracting equation number 2 from equation number 1, which leaves you with the following, which simplifies down to b being equal to 6. Once you've got this unknown variable here, b being equal to 6, and we also we can substitute that into one of these two equations to work out what the other unknown is. In this particular case, they've substituted it back into the first equation up here. You could have substituted it back in the second equation. You will get the same answer. So in this particular case, they've done that by substituting into the original equation, b being equal to 6, rearranged things, and they've found out that a was equal to negative 9 over 2. So once you have all of these values, you've got c, you've got b, you've got a, you would happily write it out and clearly say, okay, a is equal to negative 9 over 2, b is equal to 6, and c was equal to 5, which is what the question was asking you to find out. Thank you very much for listening. I hope you have a good day. Bye for now.